Hi everyone, thank you for tuning into our poster on comparing classification and regression tree methodologies on modeling survey non-response. I am Amy Lin, and I will be the narrator for this poster. And just a brief disclaimer, the results of this study is specific to the settings and cannot be extrapolated to more complex survey designs. So to start, I'd like to guide you to the upper left on the motivation of our study. Very often in surveys, statisticians use tree algorithms to model survey non-response in order to mitigate non-response bias. In 2015, Lohr et al. Presented a very comprehensive simulation study of several tree algorithms to model survey non-response. Among the R packages included in their study, they concluded that R part had selection bias and recommended against it. They found favorable results of the C-tree algorithm in the party package. Random forest methods also produced adequate results, and REEM was less effective in reducing bias, but it had benefits when there is PSU to PSU variability. And so to expand on their work, in the upper right table, we show the packages we include in our comparison. First, we left off R part since Lohr et al. Advised against it. We kept C-tree, C-forest, and REEM, but switched to more updated packages that carry these algorithms. And we also added two packages. One is the R package, RPMS, developed by Daniel Toth at the U.S. Bureau of Labor Statistics. This package is one of those that incorporates complex sample designs, such as stratification and clustering, and it also accurately applies survey weights. The other package we added is a SAS procedure called HP split. We include it in our study because it better streamlines with the SAS environment. We tested 3 splitting mechanisms under HP split: trade, Gini index, and entropy, and compared 2 pruning methods, the misclassification method and the reduced error method. For RPMS and HP split, we also compared unweighted models and weighted models. And I'll come back to the conclusions in a bit. So the sample design for our simulation study is quite simple. We use the ACS PUMS data as our frame, and we stratify it by census region. In each strata, we select a simple random sample of 2,500 households, so we have a total of 10,000 households in each of the samples. And we repeat the sample selection 5,000 times. As you can see in the lower left table, there are some unequal sampling rates going on that can be adjusted by survey weights, and we have 2 outcome estimates: the mean annual household income and the percent of insured households. You can see our results in the plots, and we also summarize our conclusions in the upper right table. So similar to Lohr et al., we found favorable results for C-tree and C-forest. C-forest had the best predictive power and the least variance, but it takes the longest to run. C-tree, on the other hand, runs pretty fast, and it had the best performance out of all the single-tree R packages. As for SAS HP split, we found mixed results. In general, results by the reduced error pruning method was more consistent with the R packages, and the results by misclassification was inconclusive. So definitely more research is needed for HP split. And finally, on the usage of survey weights, we didn't see much difference between unweighted and weighted models, although it could well be that our sample design was not complex enough to see the benefits of weighted models. We also didn't see the effectiveness of RPMS on complex surveys, which could be due to our relatively simple sample design. And so our next step is to repeat the simulation study with a sample design that includes stratification and clustering, and also to force more extreme unbalanced sampling rates to see if our PMS and weighted models are advantageous in these settings. And so this is just a very brief overview of our study. If you would like more details, please feel free to reach out to me at amylin@westat.com. Thank you.